I've been using this tutorial on how stuff works by Brain and Palette. I think it's a pretty good overview of the C language, which is the fundamental basis for MQL. So having gone through these concepts, there should be a pretty familiar ground for going through the MQL material. And today, looks like we're going to be talking about looping. Real example of looping. Oh, and then here we have the traditional Fahrenheit to Celsius conversion program. A for loop and a while loop in a Fahrenheit to Celsius conversion program. I haven't seen that before. But let's check it out. You've got the main function, which every C program requires. Sort of like the home function. You have the integer a. These integer names suck. You should always name your integers something meaningful so that you know exactly what it's holding. All right, and we got a while loop. While a is less than or equal to 100. Do some stuff in between brackets. And the stuff we're going to do is to print. Now, is that a typo? Or does it really want me to do %4d? Huh, I think they do. %4d, all right. So the %d object is the placeholder, the integer placeholder, as we've seen in previous lessons. And then we have a variable a stated afterwards. You're going to subtract 32 from it. And this is, of course, conversion formula for Fahrenheit to Celsius. Celsius to Fahrenheit. And then we're looping through this, adding 10 each time. And then at the end of the program, returning 0 to say there is an error, which is no error. If you run this program, it will produce a table of values starting at 0 degrees Fahrenheit and ending at 100 degrees Fahrenheit. And the output will look like this. Oh, it's producing a table. That's why it's skipping by 10 each time. All right, let's do it. Oh, yeah, look at that. Now, why aren't you spreading out there? That's interesting. I run this again. That time it keeps its formatting. That's weird. So pretty interesting. It's printing with a %d operator starting with 4. Now, I think %4d must mean something. If you wanted your values to be more accurate, you could use floating point values instead. And so then you would be using a float instead of an int right here. But that's really the only difference. And then you would use %6.2. You can see that the declaration for a has been changed to a float, and the %f symbol replaces the %d symbol. Yeah, but percent %f is bracketing 6.2. What is the function of 6.2? And here, percent %d is bracketing 4. That's the only thing I'm not sure about. In addition, percent %f symbol has some formatting applied to it. The value will be printed with 6 digits preceding the decimal point and 2 digits following the decimal point. Oh, that's what the 6.2 means. The float tells you how much precision you want on either side of the decimal. That is slick. Because I got to tell you, in Python, that is a major problem. Specifying how much precision you want. Say we wanted to modify the program so that the temperature 98.6 is inserted in the table at the proper position. We want the table to increment every 10 degrees, but we also want the table to include an extra line for 98.6 degrees Fahrenheit because that's the normal body temperature for a human being. All right, well, we got to try this one out. But I think I'm just going to copy and paste it. Now look okay. Load A, yeah. All right, let's run that sucker. But let's pull this window over. As you can see, it produces a table, and there it is, 98.6 degrees Fahrenheit. The human body temperature is 37 degrees Celsius. If you change the ending value to 200, you'll find the program has a bug. It prints the line for 98.6 degrees too many times. All right, let's try it. Change that to 200 and run it. Yes, it's interspersing 98.6 after it reaches 100. No, they're not going to tell me what they did. What was the difference between this and this? Well, you'd add an extra variable. Set A is equal to 0 and B is equal to -1. And then we're saying if A is greater than 98.6 and B is less than 98.6. Sorry, A is greater than 98.6 and B is less than 98.6. Then printf yeah, that's the same. 98.6, 32 times 5, that's the same. Printf, I think that's the same. A minus 32. Then this line is different. Set B equal to A. All right, let's try that. No, I made a mistake. I mismatched the brackets, yeah. Need an extra bracket here. No. Hmm. Yeah. This whole thing is between brackets. There you go. That did fix it. Do we understand why? That's the crucial thing. Do we understand what was the essential improvement in this? They've added a negative one, meaning false. And then we're saying negative one is assigned to 0. I think it means if you got to this line and set b to true, huh? I wish they'd spend a little more time explaining this, because that is interesting. You've got b minus 1, a is 0. And then you're incrementing a by 10 each time. You've got b being set to the value of a. And you're looping a through 100. All right, so as last time it mentioned that when you mix up equals and double equals, you're going to be in a world of pain. Forgetting to increment the counter inside the while loop. Yes, if you don't increment the counter, you'll get an infinite loop. The loop will never end. Accidentally putting a semicolon at the end of a for loop or if statement, so the statement has no effect. Right? It's not necessary to put a semicolon at the end of an if statement or the while statement. Essentially because it's not done, that's not complete until you've mentioned what it has to do. You have put the material in the brackets there. And in JavaScript, for example, at the end of every function, you have to put a semicolon, or you're supposed to. C is a little different. You don't have to do it. Or you don't actually do it at all. This loop would print out one value because the semicolon after the for statement acts as the one line for the loop executes, right? So it wouldn't execute material in the body, so it would be done. Try changing the Fahrenheit to Celsius program so that it uses scanf to accept the starting, ending, and increment value for the table from the user. Okay. All right. Challenge. Challenge accepted.
2 hours later.
The previous video because I'm so proud of myself for having figured this thing out after what took a little bit of time. So here's the original program. So what I'm going to do is cover up my solution, put in the original program, and let's run it. Okay, so that works for values under 100. Let's change it to 200. And that solves it. So Let's look at what it asks us to do. Come on, you. Try changing the Fahrenheit to Celsius program so that it uses scanf to accept the starting, ending, and increment value for the table from the user. So after I got over my initial flusterment, I figured out how to do that. So let's see. First of all, let's make some more descriptive variable names. A is the starting value of this conversion program. So I'm going to change all the instances of A to start value. All right, that's start value. That's a start value. That's a start value. That's start value. There's a start value. That's a paddling. And there's a start value. Yeah, we'll keep that for now. Start value. Start value. Start value. To keep things a little clearer, we have B, which is basically the bug fix value. But we're also going to need an end value. So let's declare that. And then we're also going to need an increment value. So let's declare that too. All right. Now here, the start value is being given for us starting at 0, but they're basically saying changing it so that you can use scanf to add the starting, ending, and increment value. So you can basically specify by user input what the start value should be. So I'm just going to replace this line with a printf, which says, hey, enter a starting value. Then I'm going to scanf to enter it in using %f, the float placeholder. And then you use the address operator for start value. This is the start value. Input. All right, we're going to leave that for now. And then we also are going to need the end value. So again, we'll solicit the user to enter an end value. And then we'll scanf again with %f. And use the address operator for end value. Okay. And then we're also going to need a increment value. So I'm going to print enter an incrementing value. That's an unnatural way of saying that. How would you actually do this for like a thermometer? Enter a temperature increment? I guess that's a little better. And then we're going to scanf %f again. Ampersand increment value. All right. Does that look okay? It looks okay to me. Now, here, the n value is specified for us, but we want to use our new variable n value. And then should just test that right now. Yeah, let's just test that right now. All right, enter a starting value. We'll just start with 0. Well, actually, no, let's do something different. 20. Ending value, want it to go up at least to 200. And the increment will do something different. Let's do it by 5 this time. All right. So that worked. We got our table of values. We got this extra 98.6 degrees value for the human body temperature, and we don't have that bug. And we use scamp. So there's the first requirement. The second thing it says is add a heading line to the table that is produced. Well, that kind of threw me for a loop, and I realized it could be something very simple. And it doesn't even have to be, it doesn't have anything to do with the loop. We could just do this. Print table of Fahrenheit to Celsius conversions, something like that. Oh, and then let's do a couple of new lines. All right, that's it. Let's just run this. Oh wait, I made a mistake. Oh yeah, we got a semicolon after a print statement. Okay, again, starting value. Let's do 10 this time. Let's do 150 this time, and let's do temperature increment 20 this time. All right, so there's our header. Table of Fahrenheit to Celsius conversions. I think that's good enough. I think that's a header line requirement. And then try to find a different solution to the bug fixed by the previous example. Okay, now this one I think was the trickiest part. But once you understand what causes the bug, you're halfway there. This bug happens because there's a loop here and a conditional, which doesn't get activated in the first few times. It's because, look at the condition. It says start value is greater than 98.6 and this extra little variable is less than 98.6. So in the first few times that you run this, this is always going to be false because the start value will not be greater than 98.6. So it's always skipping this function. No, this statement here is never getting run. It's doing this one, which is all tickety boo. Then when start value becomes greater than 98.6, the variable b is still -1. So this becomes true once and once only. And it prints this special line. Or this part is, I actually don't really understand what this does. This little bit right there. I don't really get it. I guess it's just putting in the statement 98.6 right here. And then doing the conversion using this formula, and you get 37 degrees. The problem is, once start value is greater than 98.6, without this extra variable here, this is true. And so it's going to do this statement here, which does the incremented temperature value, and then goes back and prints this again, which is why you get those 98.6s interspersed through the new values. So let's see that in action. I'm going to get rid of this line here, and I'm going to get rid of this line here. You see what it's doing is once this has been printed once becomes true, then it skips down to this one. It sets the value of b to whatever the increment to whatever the start value is. Right, start value starts low, and so b is going to be less than 98.6 in the first few bits. Then later on, once this becomes true and gets printed out, then b is going to be equal to that start value that is bigger than 98.6. And so this becomes false. That's why this bug fix works. It only prints this part one time because of it. But now that I've commented it out, we'll see the bug. Let's do it. Enter starting value. Let's do 0. Enter ending values to at least 200 or over 100. And the temperature increment, let's just do 10. There you go. There's the bug. So the challenge is, let's find a solution to this that is different from the one that they came up with. And it took me quite a bit of thinking because I'm not that smart, but I figured it out. What we can do is basically say, hey, right over here, we don't need this. We don't need the variable b at all. Let's leave it commented out. And we don't need to change anything over here. We just have to do a different check with start value, which is that, we want start value to be greater than 98.6. We also want start value to be less than whatever the next increment value is, whatever that user puts in. I see you could try to do things like, say, like if it's greater than 98.667 or something very close to the value, but that's the thing. We don't know how fine an increment value the user has chosen. And since we're using floats, they can pick a very specific value. So this is at least one way to make sure that this works using any user input. I think should be all right. So basically, I want start value to be. Wait a sec. Yeah, I want start value to be less than 98.6 plus the increment value. Right. So basically, if the start value is greater than 98.6 and less than 98.6 plus whatever increment value they selected, then you run this line once. As soon as the next increment has been added, this condition right here should be false. So it'll never run again. And let's just see if it works. So we'll do the same thing. Start with 0, 200, 10. Booyah! Booyakasha! It has printed once. We didn't need an extra variable. We didn't need that b variable. All I know is I declared it here. Let's get rid of it. See if that still works. 0. Whoops. 210. Yeah, it still works. That b is totally unnecessary now because we're just checking the start value plus the value of 98.6 plus the increment value. So there you go. Can't really consider myself a programmer yet, but I think we're making progress because I would never have been able to do that a few months ago. So onwards and upwards, Excelsior. Thanks for watching, and I will do this next time tomorrow.